Hello everyone, welcome to Pepcoding. Today we are going to solve a question named add in Doubly linked list. Okay, so first of all, let's go and see the question what is about. After that, we'll look for the solution. Okay, so in this question, we are given some partially written doubly linked list. Just see, this is the doubly linked list class that we have, and inside this we have some functions. Here we have some exceptions. One is list is empty exception, and another is index is invalid. Okay, now let's move forward. There are some basic function and there are some add function like add first node, add first. We have done these questions in the previous videos. If you haven't watched those videos, please visit to our channel and watch these videos. Okay, so this is add first, add last node, add last, and after that this is add function that we have to write. Okay, so this is question all about. So in this, what we have to do, we are given an index and a data. We have to add that data at that index in the doubly linked list. Okay, let's move forward. There are some remove functions: remove first node, remove first, remove last node, and remove last. Okay, and then there are some get functions, that is get first, get last, get node add, get add. Okay, after that this is our main function. So now let's move towards the board and see what we have to do, what is our target and what is our we have to achieve. Okay, so we are here. Just suppose this is the given doubly linked list we have. So what we have to do, we are given some index here and we have to add the given data at that index. Okay, so let's move forward. Yes, so here we have index from 0 to 7. Okay, so if someone says us to add something at index -1, what will be your answer? It will be like it isn't possible to add something at index -1 because that index doesn't exist. Indexing starts from 0. Okay, so for that the function we have here, that is called index is invalid exception. Okay, we check that with this exception. We have one more exception handling function here, list is empty, but there is no need to check this function in this question because if just suppose we can have an empty linked list, and then we have to add at index 0. Okay, so this is possible. That's why this function is not useful for us right now, but this will be useful when removing add node. In that question we will use this function. Okay, so now let's move forward. So this is a given linked list we have. So what we have to do, we have to add something at an index. Just suppose if someone says you have to add at index 2. Okay, so what will happen, after 1 that node will come. Okay, not this node, and all these nodes will be shifted by 1. Okay, so we have to do that. So now let's move towards that and see how we are going to do that. Okay, so we are here. So first of all, let's go and we will start with handling the exception. This is the list of add. Okay, here this is add function that we have to write. Okay, so what we are going to do, first of all we are going to handle the exception. So if the given index is out of range, like from 0 to the length of the linked list, if it is inside this it is fine, but if it is out of this it is not fine. So there is a function, what was the name? Index is exception, index invalid exception. So we will copy this function and call this from our function. So inside this we are going to pass some values. What was the values? First is index, the second is the left range, and the third is right range. Okay, so let's go and discuss what will be the left and right range. Index is simple, we will pass the index. So what is the left range? Just suppose, as we have discussed, -1 is not allowed, but 0 is allowed. Because what is 0? 0 is adding a node just at the start. We can add at 0. Just suppose we will add that here. Okay, now it is 0, it is 1, it is 2, and it go all. Okay, so we can add the node at index 0. So 0 is valid. Less than 0 is not allowed. In the same scenario, if we have to add something in the last, like just suppose someone gave that we have to add at index 8. Okay, but we have only 7 index, but we can add at 8th index because we have some area left here. Okay, just suppose we erase this. After that, yeah, surely we can add something here and it will be at index 8. Just suppose the value is 6. Okay, this is done. So this is possible. So what will be the range? The range is, the left range will be 0. If it is less than 0, what will happen? It is invalid index. If it is greater than the length of the given linked list, then it is invalid. So let's go and write that range of ours. So the left range is 0 and the right range is this dot size. Okay, so this is done. Now what we have to do, let's move forward and see what we have to do inside this. If it is true, so what we will do? If this is true, so we have to print this index is invalid and -1. So let's go and see that function here. Index is invalid is already printed. What we have to print? We have to print -1. So we will print -1 in this function. So system.out.print -1. Okay, this is done. Now we are out of this. After this, what do you have to do? If it is a valid given index, then what we have to? Then we have to add that index. Okay, so first of all, we need to make a node for that. So node equals to new node with the given data. So we have made a node with the data inside it. Now what we have to do? We have to add that node at the given index. Okay, so we will call the function add node at, and we will pass the index inside this and the node that we have made, and believe that this function will do that work. Now let's go and define this function. Okay, so public static void add node at, what we have, one index and the other is node. Okay, inside this function, what we are going to do? We are going to add that node in the given index. So inside this, first of all, what we have to do? Let's go on the board and discuss that first. We are here. Okay, suppose if the given value of index is equals to 0, what it means? It means we have to add that here. We have seen that we have to add a node here. Okay, so if we have to add here, don't you seems familiar that it is like adding add first? We have done that question. If you haven't, just go and watch the video before. No, just go and solve that question. If you stuck, then watch the video. Okay, so I always prefer to solve question myself first. After that, if you stuck, then watch only. Okay, so this is similar to add first. Okay, so don't we use the same function that we have here? Just see, we have a function here, add first node. Okay, and what oops taught us? It taught us that we should use function many times. Like we have a written function, we don't need to write it again and again. We have to use the same function, so we don't need to write this in the same function here also. We just need to call that function. Okay, so inside this, what we'll do, if the given index is equals to 0, what we will do? We will call add first function. So add first, inside this we will pass our node. Okay, so this is done. Else what we'll do? Okay, let's match the spelling for add first. It was node, add first node. Okay, so let's go add first node. This is done. Else if the second question is, just suppose if the given index is the equals to length of the given linked list. So what we'll do? It will be similar like adding at the last. This question we all have also done. Okay, this was like add last node. So we will use this function. So we'll copy this and we will use this here. Else if the index is equals to this dot size, what will happen? We will call this function. It is add last, and we'll pass the node inside this. Okay, so what is the third case? Let's go and see what is the third case that we have to handle here. Okay, we have to make believe that these function that we have called, this will do its work fine, because we have done this question, we have seen these functions are working very fine. So inside this else function, what we are going to, when we are inside this else function, what it means, let me tell you first. We have handled less than 0 already here. We have seen that here. When we have to add art, we have handled that in the exception, less than 0, and greater than the length, we have also handled that here in the exception. So and 0 and at last we have held that here. Adding at first and adding at last, that is handled here. It means 0 and which index is this? This is the 8th index. That is also handled. Now we are left with 1 to 7 for this linked list. Okay, so what we are going to do? We are simply going to pick up the node first. Okay, now let's see how. Okay, so let me make some space here. It is very clear now that the given range is now from 1 to 7. Okay, now let's go and see. Just suppose we have to add at index 5th. So what we have to do, there will be one node that we will make. Just suppose the value is 6 inside this. Okay, so after that, what will happen? We will shift every index by 1. It will be 6, it will be 7, it will be 8. And let's erase this. This was not there. This was just for the explanation. Okay, remove this also. Okay, this is also done. So now let's go and see. So this will be the 5th index for this now. And what will happen? Here, this link will be removed. And what will happen? New link will be made. What that will be? That will be like this, this, and this, and this. Okay, so after that, what will happen? Let's see. We have achieved our target. This is at the 5th, this is at the 6th, this is at the 7th, and this is at the 8th. Okay, so for this, what we are going to do, just suppose when we broke this link, our this node is lost. So before breaking, like before making this new bond, we have to save this somewhere. Okay, and for reference, we have to save this node also. So what we are going to do for that, we are going to use two variables. One is forward and one is previous. We will save forward in this, like this is the forward node for our given node. That's why I given it a name forward. And this node is the previous node for our given node. That's why I named it previous. You can use it. Okay, so what we are going to do, we are going to use a variable to store the address for this node, else it will be lost. Okay, so now let's go and save this first. Save the node that we are going to lose if we break this bond without saving it. So let's go here in the else part. First of all, we have to make a list node forward. What it is, inside this we are going to save the index, save the node at index that we have to add. Okay, so we will going to use get add. This is the function we have written here in the get section. In the get function, we have function get add, get node add. Okay, this returns the node that we need. Okay, get node add. We will use this function. So let's go. Yeah, get node add. Inside this, we will pass our index. So our that node is safe now. It won't be lost. After that, we have to save the previous node also for making the link. So we are going to use that list node, and it is previous. So equals to what will it will be the previous of the forward node. So forward dot previous. This is done. Now the both the nodes are saved. Now we can simply make the link. So what will happen? Let's go and see. Here in the next of the previous, our node will come, and in the previous of our node will be the previous. So let's go and make this connection first. So in the next of previous, our node is present, and in the previous of our node, previous is present. This is done. Now what we have to, now we have to make this link. And what is this link? The next of our node is forward and the previous of our forward is node. Let's go and apply that also. So node dot next is equals to forward and forward dot previous is equals to node. This is done. So this is all just code about. We don't need anything else. Now let's go and run this code. We have some error. Okay. Let's see what is the problem we have here. Cannot be different from static context. Okay. We have to remove this. Let's run this now. Okay. We have some typing mistake, I think. At line number 101. List node forward. Get node at index. It seems fine to me. Let's see what is the problem. Class list node. I think we have written the code in the section. No, it is good. Okay. Node at. Okay. We've called the function get node at. Okay, let's see. Is it right? Cannot find symbol. List node pre. Okay. We have to use the node. By mistake, I have written the list node here. This is the node that we need. Okay. So now let's run this. Okay, we made something. Okay. I write previous dot next. It will be pre dot next. We have defined the name with pre. Let's run this again. Okay, so this is successful. Now let's submit this for all the test cases. Okay, test case 2 failed. Okay, and 4 failed. Okay, 2 test cases failed. Now let's see why it is failing. I think, yeah, we forgot to increase the size. Like every time node is added, the size of the given linked list increased by 1. Okay, so don't forget to do that. We have to increase the size by 1 every time we add a node. We have successfully added a node here, so size increase. Inside this, when we added at 0 and we added at the last, what happened in this function? Add at 0 and add at last. Add first, where it is, yeah, here they manage the size. This dot size was increased, but when we added in the between of that range, we haven't increased. That's why the test case were failed. Okay, so now we have managed that. Now let's run this code again. Okay, now let's submit it. So all the test cases pass. I hope you have learned something. Before going, let's go and dry run the code for ourselves. Okay, we just have to dry run this part. Okay, now let's go on the board and see what we are doing here. Just see, first of all, let me erase this and make a proper linked list. Okay, this is gone, this is also gone. Okay. Yes, exactly. Now let's go. Okay, yes, this was 5, this was 6, and this was 7. Okay, let me erase this also. So let's try our code for like 2-3 test cases by ourselves. So just suppose we have to add at index 1. What will happen? First of all, this node will be saved, because if this link is broken, this node is gone completely. From here to here, all the linked list is gone. So we have to save this node. So in the forward variable, we have saved this node. So this is save here, and we have saved this node also, because previous node we need to make the connections. So in the previous, we have saved this node. After that, we broke this link, created a node that we have sent. We make this link after that. Okay, So this link is broken after that. So let's erase this. Okay, this link is gone. Now what happened? We make in this link, like in the next of the previous our node, and in the previous of our node, the previous is available. After that, what we have done, we have made this connection. So in the next of our node is forward, and in the previous of our forward, our node was present. So don't you think that this is the doubly linked list that we have, that we were desiring? Because automatically after 0, one index is here. This will be 2, this will be 3, this will be 4, this will be 5, this will be 6, this will be 7, and this will be 8. So our desired output is here now. Now let's go write in it for some other place. Okay, this was a double linked list. Now just suppose we have to add index 6. Okay, so what we are doing, at index 6, if we have to make, first of all we have to save this node. So we have saved that in forward. Okay, and after that we have saved this in previous. We made a new node that we have sent. It is here with value 6. After that we break this bond and connection this bond. So let's erase this. Okay, this is broken. After that this bond was made. Okay, this is done, and after that this bond was made. So automatically this became at level 6, this is gone at 7, and this is gone at 8. So yes, our code is perfectly working for all the test cases. Okay, so thank you so much for being here. I hope you have learned something. Please like and share the video and subscribe to the channel. Thank you so much.